Hi, I noticed some issues with section 15, question 5, or the quick check 5 within the reading, and I just want to make sure that everybody's clear on this concept. This is to think about the zeros and multiplicity of a polynomial function and determine which graph can match that particular description. And so let me just remind you that if a zero has an odd multiplicity, then the graph will have to go through that zero. It's going to cross through it. If it has an even multiplicity, the graph is going to have to bounce off of the axis at that point. And so we think about this first description. It says that we have zeros of -2, -1, 0, 1, and 2, each with multiplicity 1. So that means we need to try to find a graph that's going to cross the axis at each one of those zeros. And so I'm really looking for one that has no bouncing off the x-axis. And if I think about that, here I see that the graph in graph D, it's crossing through -2, it's crossing through -1, crossing the axis at 0, crossing at 1, and crossing at 2. So graph D is the one that represents this first description. The second one says that we have zeros of -2 with a multiplicity 1. -1 has a multiplicity 1. 0 has a multiplicity 2. 1 has a multiplicity 1. And 2 has a multiplicity 1. So the only even multiplicity is at 0. So the graph is going to cross at -2, cross at -1. It's going to bounce off at 0, cross at 1, and cross at 2. Now, it may not be in the direction that I've shown there, but the only place it's going to bounce is at the x-intercept of 0. And so if we look at this, notice that it's bouncing here and here. So there it has 2 bounce points, so it's not graph A. Graph B has 2 bounce points, so it's not graph B. Graph C, it's crossing at -2, crossing at -1. There it is, it's bouncing at 0, crossing at 1, and crossing at 2. So graph C is this second description. Then the 0 of -2 with a multiplicity of 1. -1 has a multiplicity of 1. 0 has a multiplicity of 2. 1 has a multiplicity 1. And 2 has a multiplicity 2. So it has 2 bounce points, specifically at 0 and at 2. So if we look at this one, there are 2 bounce points to graph A, but they're at the wrong location. That's at -1 and 1. Graph B, right, it's bouncing off at 0 and bouncing off at 2. And then notice that it crosses at the other intercepts. So graph B is a one that is represented by that description. Obviously, process of elimination tells us the last one is graph A, but just to confirm, it has a 0 of -2 of multiplicity 1, a -1 of multiplicity 2, a 0 of 0 with multiplicity 1, a 0 of 1 with multiplicity 2, and a 0 of 2 with multiplicity 1. So the only bounce points there should be at -1 and 1, which is exactly what we see in graph A, because every other 0 is crossing. So graph A is the correct one. So let me know if you have any questions on this concept. I'd be glad to help. Thank you.